will learn about line graph. Sometimes data also changes with time. For example, the number of students in the class may change on different days. Such data can be presented by a line graph. Similarly, the distance traveled by car at different times can also be changed, which can be presented as a line graph. A fruit seller's earning for each day of week can also be changed, which we can represent as follows. A line graph is shown here. Can you tell me what information it gives? Think. This line graph gives us information about the sales made by a watch manufacturer every month. You can see that the sales of watches in various months are shown with different points which have been joined by line segments. Similarly, in graphs, data is represented by points which are linked by line segments. The figure shown tells us that different watches have been sold here in different months. Similarly, the line graph shows the change in statistics over time. This shows us the pattern of data. Like here, we see that sales have decreased from January to March, whereas after March, the sales have increased. Similarly, among all the months shown, the least number of watches are sold in March. Let us learn to draw a line graph with an example. A car travels 250 kilometers from its starting position A to position B. The distance of the car from place A at different times is shown in this table. Now, represent this data on the graph. We will take a graph paper. On this, horizontal line will be drawn, which is called x-axis. We will show the time on x-axis. Similarly, we will draw a vertical line, which is also called y-axis. On this, we will mark the distance of the car from position A. To show this distance, we will take 1 unit is equal to 50 km scale on the vertical line. Now, we will mark the data by points. At 12 o'clock, the distance of the car from position A is 0 km. So, we will mark the point at intersection of the vertical line at 12 o'clock and the horizontal line representing 0 km at 12 o'clock. Similarly, at 1 o'clock in the afternoon, the distance of the car from position A is 50 km. So, we will mark the point at the intersection of the y-axis and 1 o'clock in the afternoon at the horizontal line representing 50 km. Similarly, we will mark all the data given in the table. Now, we will connect these points with the line segments. From this, we will get a graph of the distance of car from place A at different times. With the help of this line graph, we can now tell the position of the car at given time. With the help of line graphs, two groups of data can be easily compared, which we will understand with some examples in the next video. Today we have learned about line graph. In the next video, we will learn interesting examples related to this. Today we will see some interesting examples on line graph. Look at the line graph shown. What information is displayed in this graph? The graph shows the months on the horizontal axis and the number of motorcycles sold on the vertical axis. In this way, the continuous line shows the number of motorcycles sold in different months of the year 2007 and the dotted line shows the number of motorcycles sold in the various months of the year 2008. The graph shown in this way compares the number of motorcycles sold in various months of the year 2007 and the year 2008. How many more motorcycles were sold in March 2008 as compared to March 2007? It is observed from the graph shown that 120 motorcycles were sold in March 2008 and 60 motorcycles were sold in March 2007. The difference between the two numbers is 120 minus 60 is equal to 60. So, we can say that in March 2008, 60 more motorcycles were sold than in March 2007. Find the month from both years in which the number of motorcycles are sold equally. In the graph, the continuous line and the dotted line intersect at a point. The intersection point is located in April month. This tells us that in both years, the number of motorcycles sold in the month of April is equal. Let's see the next example. Ramesh planted a plant. At the end of each week, he found the length of the plant, which was as follows. Consider scale as 1 unit is equal to 2 cm. Represent the given information in a line graph. A line graph represents data that changes continuously over time. Data is displayed by dots in the line graph. Now, let us draw a graph based on the information shown. Draw two mutually perpendicular lines on the paper. The horizontal line is the x-axis and vertical line is the y-axis. We will show the time in the week on the x-axis. Similarly, we will show the length of the plant on the y-axis by taking a scale of 1 unit is equal to 2 cm. As the maximum value here is 11 cm, we will end the length on the y-axis by a greater number such as 12 cm. Now, we will mark the data by point. Initially, that is, plant length is 0 in 0 position. Therefore, we will mark the point at 0. Similarly, the length of plant in week 1 is 2 cm. To denote this length, we will mark the points at the intersection of the vertical line of week 1 and the horizontal line of 2 cm. Similarly, the length of plant in week 2 is 7 cm. To denote this length, we will mark the points at the intersection of the vertical line of week 2 and the horizontal line 7 cm. Similarly, we will mark the point for all observations. Now we will connect all the points with line segments. We have shown an increase in plant length over time as a graph. Therefore, we can call it a graph of time growth. Today we have seen some interesting examples on line graph. In the next video, we will see some more examples. Today we will see an example on line graph. Which of the following graphs shown below are possible between time and distance? In the first line graph, distance is also increasing with time. Is this possible between time and distance? Think. Absolutely right. It is possible that distance increase with time. For example, the distance from the start of a vehicle's journey increases over time. The distance traveled by a rocket also increases with time. Therefore, we can say that line graph 1 can be a time-distance graph. Line graph 2 shows a situation in which time is increasing but the distance is the same. Is such a situation possible? Think. Let me tell you, yes, such a situation is possible. If during the journey, the car stops somewhere before reaching the last place. So, in such a situation, time will increase but distance traveled will remain the same. Hence, line graph 2 can be a distance time graph. The distance is decreasing with time in the situation shown in the line graph 3. While returning from a starting place, the time increases, but distance from starting place will decrease. Therefore, the situation shown in the line graph 3 is possible. Therefore, line graph 3 can be time distance graph. Now, can you tell me that line graph 4 shows which position? In the line graph 4, distance is increasing but time is constant. This is not possible. Therefore, there cannot be such a graph between time and distance. So today we have seen another interesting example related to line graph. Today we will learn Introduction to Coordinate System and Linear Graph. This shelf contains several boxes. Can you tell the location of this box? Think. Let me tell you, to determine the location of this box, we need the number of rows and number of columns. If we start with 0, from this corner, we can number the rows in this way. Similarly, we can number the columns in this way. Now, we can say that the desired box is in the second column and the third row. This understanding of determining the location in a plane helps us in many situations, such as to find the exact location of a seat in a theater, to indicate the correct location of our house in a building, to indicate the correct location of a book in a library, etc. In all these situations, we unknowingly use the coordinate system. The method of expressing a position from a group of numbers is called the coordinate system. With the help of this method, we can determine the position of a point in a plane. For example, there is a graph paper showing the x-axis and the y-axis. They are perpendicular to each other. Their point of intersection is called origin. Assuming the origin point as 0, we represent numbers on the x-axis and the y-axis. If we take a point A on the graph, we can say that its position is represented by the number 2 of x-axis and number 3 of the y-axis. According to the coordinate system, we represent the location of point A, 2, 3 in this way. We say that 2, 3 is the coordinate of point A. It has 2, the x-coordinate of point A, and 3, the y-coordinate of point A. Similarly, the position of point P on the graph can be expressed in the form of x-coordinates and y-coordinates xy in this way. If we are given the coordinate of a point, then with the help of these, we can determine the position of the point in the plane. This process is called plotting of points. Here are some points and their coordinates. Can you plot them using the coordinate method? Try it by pausing the video. Let me tell you, we see that the x-coordinate of point A is 1, which tells us that we have to move 1 unit to the right from the original point. Since the y-coordinate is 2, we now have to move 2 units up. We will mark point A at place obtained. Similarly, will you be able to find the location of point B? Try it. Absolutely right. The location of B can be found from x-coordinate 2 and y-coordinate 4. Similarly, we can show the location of point C and point D in this way. Let's connect all these points with line segments. You can see that line segments AB, BC and CD lie in the same line. Thus, if all the line segments in a graph are part of a single line or in same line, then such a graph is called a linear graph. We will understand it better by some examples in the next video. Today we have learned Introduction to Coordinate System and Linear Graph. In the next video, we will see some interesting examples related to it. Today we will see some examples on the coordinate system and linear graph. Find the coordinates of the vertices of the shown figures. The graph shown shows two figures, quadrilateral LMNO and triangle PQR. Let us find the coordinates of vertices of quadrilateral LMNO. We see that the x-coordinate of the vertex L is 2 and y-coordinate is 4. Hence, the coordinates of the vertex L are 2 and 4. Similarly, we see that x-coordinate of vertex M is 0 and y-coordinate is 2. Hence, the coordinates of the vertex M are 0, 2. The x-coordinate of vertex N is 2 and the y-coordinate is 0. Hence, the coordinates of the vertex N are 2, 0. Similarly, the coordinates of vertex O are 4, 2. We can say that the vertices of quadrilateral LMNO have coordinates 2, 4, 0, 2, 2, 0 and 4, 2. Now, find the coordinates of vertices of triangle PQR by yourself. Next example. Nimrat goes to school every day on bicycle. On a day, it took her 25 minutes to reach the school, details of which are given in the following table. Represent the given information in the form of a line graph with appropriate scale. Is this graph a linear graph? A line graph represents data that change continuously over time. Data is displayed by dots or points in the graph. All points are joined by line segments. If all the line segments are part of the same line, then we can say that it is a linear graph. Let us draw a graph based on the information shown. Draw two mutually perpendicular lines on the paper, the horizontal line x-axis and the vertical line y-axis. We will show time in minutes by taking 1 unit is equal to 5 minutes scale on x-axis. Similarly, we will show distance on the y-axis by taking 1 unit is equal to 0.5 km scale. We will now plot the points for different situations. A distance of 0.5 km has been covered in 5 minutes. We will mark point P on the coordinates 5, 0.5, which will represent this position on the graph. To show this on the graph, we move 1 unit to the right from the original point. Then 1 unit will move upward. This will bring us to the point P. Similarly, coordinates of other points Q of 10, 1, R of 15, 1.5, S of 22, T of 25, 2.5 can be taken here. Pause the video and think about their position. Let me tell you, we can represent them in this way. Now we will connect all the points in the sequence according to the line segments. We have represented the distance traveled by time as a graph. All the line segments of the constructed graph are part of same line. So we can say that the obtained graph is a linear graph. Today we have seen examples on the coordinate system and linear graph. In the next video, we will see some more examples. Today we will see some more examples on coordinate system and linear graph. Below is the map of Amina's city. Suppose the x-axis represents the horizontal road and the y-axis represents the vertical road, and Amina stands at the intersection. Read the map and answer the questions asked. How will Amina's location be represented in the coordinate system? Amina's location can be represented by x coordinate 0 and y coordinate 0. So her location will be 0, 0. We can call it the origin. If Amina had to represent the position of post office in the coordinate system, how would she be able to do this? The location of post office can be represented by x coordinate 1 and y coordinate 2.5. Hence, the position of post office will be represented by 1, 2.5. Which places do coordinate 3, 5 and 2, 4 represent? Number of coordinates 3, 5, where 3 is x coordinate and number 5 is y coordinate. Can you now tell which positions the coordinates 3, 5 represent? Think. Let me tell you, the x-coordinate 3 tells us that we have to move 3 units along the x-axis, that is 3 kilometers here. Similarly, y-coordinate 5 tells us to move 5 kilometers along the y-axis. In this way, the coordinates 3, 5 here tells us the location of a ration shop. Similarly, the number in coordinates 2, 4, 2 is x-coordinate and number 4 is y-coordinate. Coordinates 2, 4 represent the railway station. How will the location of the vegetable market be represented as coordinates? The location of vegetable market can be represented by x-coordinate 1 and y-coordinate 3.5. So, the location of vegetable market will be represented by 1, 3.5. Next example. If the y-coordinate is 3 times the x-coordinate, make a table for it and draw a line graph. Is the line graph a linear graph? Let's represent y-coordinates with variable y and x-coordinates with variable x. We are told that the y-coordinate is 3 times the x-coordinate. So, we can say that y is equal to 3x. Let's make a table from this. If we take a value of x as 0, then the value of y will be 3 multiplied by 0 is equal to 0. If we take the value of x as 1, then the value of y will be 3 multiplied by 1 is equal to 3. Similarly, if the value of x is 2, then the value of y is 3 multiplied by 2 is equal to 6. Similarly, we will find the value of y for different values of x. Now, we will draw a graph using this table. Step 1. We will draw the horizontal line x-axis and vertical line y-axis on the squared paper. Step 2. We will show variable x on x-axis and variable y on y-axis. The scale for the x-axis will be 1 unit is equal to 1 and the scale for the y-axis will be 1 unit is equal to 3. The largest value of y is 12, so we will take up to 15 numbers on the y-axis. Step 3. Now we will find the location of points according to the scale. When the value of variable x is 0, then the value of variable y is also 0. That is, in the first case, both the x-coordinate and the y-coordinate are 0. So, we will draw a point in place of the origin. When the value of variable x is 1, then the value of variable y is 3. So, we will move 1 unit to right from the x-axis and then 1 unit upwards. We will now mark a point at this place. This point is the coordinate 1, 3. Similarly, we will move 2 units to the right from the x-axis and 2 units upward. Now, we will place a point that is coordinates 2, 6 at this place. After this, we will also mark the coordinates 3, 9 and 4, 12. Step 4. Now, we will connect all the points with line segments. Thus, we have shown various values of variable x as a graph. We see that all the line segments obtained are part of the same line. So, we can say that this is a linear graph. Today we have seen some more examples on the coordinate system and the linear graph.